Okay, on this video we are gonna learn how to work with the calculator using TI-84 because you have to the mathematics without the learning how to work with the calculator is very essential to learn this important things that what this calculator does. Okay, we start from the beginning. We talked about integers, and then we talked about fractions, and then radicals, square root, and cubic root, and all these. Oh, now we are going to show it on calculator how it works. You turn on this one by second on, and then you clear clear the screen. Okay, we say like if you want to write expression like 3 times 3 equal to 9, and then see sometimes you got to use this one. It's necessary to use this one, like minus 3 times 6. See, so when it's positive, you don't write the positive sign behind the 6. You just positive number 6, positive 6 is equal to minus 18. And then we talked about we are going to talk about the exponential, the number that has exponent, the exponential numbers. Like you say 2 to the power of, if we say just to the power of 2, we push this one. It's going to be equal to 4. 2 times 2 means we multiply 2 times 2, good, 4. Now how about 2 to the power? Okay, if it's more than 2, the power, use this one. You can now raise to anything, to any numbers by pushing this one. Now to the power of 3, what is going to be? It's going to be 8. Because 2 times 2 times 3, 3 times base is multiplied by itself. 2 times 2 times 2 is equal to be 8. So accidentally, if you push this one, for example, and you don't know how to come back, you gotta use this one, second and mode, quit. At the top of this it say quit. So you come back to the screen. If you want to raise 2 to the power of minus 3, see, you got to use this one, minus 3. It's going to be what? Minus 8, 2 times minus 3, 2 times minus 3. See, what is, I said minus 3, if it's 2 to the power of 3 is going to be 8. But what is happening actually is the same as write it in a positive integer, positive exponent. What we do, okay, put alpha and then this one, and then enter. See, this is you can write the fraction. Actually, 2 to the power of minus 3 is 1 over 2 to the power of 3. It's going to be minus 1. 1 okay, it's going to be 1 over 8. Okay, no, let me See, at the top here is 0.125. Means this is the same. Okay, 1 over 8. 1 over 8. It actually what it did, 1 over 2 over 3. 2 over 3 is 8. So 1 over 8 is going to be 1 over 8. Oh, okay, you want to write it in a decimal form. What you do, you see the decimals here? The answer here, we take the answers 1 over 8 is equal to 0.125. We change it to fraction, or if you want to change this one to we change this fraction in a decimal way. So if you want to write it again in a fraction, you use math, the first one, you enter the first one highlighted, fraction, and then is 1 over 8. So let's clear this. We go back, we talk about other subjects. So about fractions. What you do, like you want to add two fractions together. Okay. See, you can use, one of the ways you can use this one, n over d, the first one highlighted, and then you enter. You can write the fraction like 3 over 3. We bring the cursor down. 3 over 5 times 3 over, look, okay, say like times 3. What's gonna happen? 3 actually is 3 over 1. Numerator is gonna be multiplied together. It's gonna be 9. So the result is gonna be 9 over 5. Add two fractions. This is the multiplication of fraction by a number, by integer. Now we show an example of fraction adding two fractions. Say alpha, and then this one, the first one we choose, and say like 4 over 5 times another fraction times 3 over 4, for example. 3 times over 4. See, the numerator multiplied by each other, 3 times 4 is going to be 12. 4 times 5 is going to be 20. So the answer is going to be 12 over 20, and then it simplifies also for you. Means actually 3 times 12 over 20, if you multiply, is going to, if you simplify, is going to be 3 over 5. Okay, it's going to be 3 over 5. So we divide both numerator and denominator by a number. You see, when you see that, like for example, we say you are going to multiply 2 over 3. See, if you want to multiply this, let's talk about we talked about addition, multiplication, and then we talk about division, and then we talk about other things later related to this. Divided by okay, divided by 4 over 5, for example. See, is 5 over 6. 5 over 6. What it does, actually, what we can do, we can say 2 over 3 times, we invert this and we do the multiplication. We say 5 over 4. See, we invert those. See, we get the same answer. See, so the multiplication here, here we divide 2/3 by 4/5. Okay, we got 5 over 6. We could do the other way around. You know, I mean, the best way you could do is when you have a division, you reverse the second one. This one, 4 over 5 by 5 is going to be 5 over 4. So it's going to be the same answer, 5 over 6. Actually, it's going to be 2 times 5 is going to be 10 divided by 3 times 4 divided by 12. I know you want to change it to fraction. Math, fraction, and then you get 5 over 6. So actually what happened, the system divide the numerator by 2 and numerator by 2 and denominator by 2. If you divide 10 by 2, it's going to be 5, and divide 12 by 2 is going to be 6. So the answer is going to be 5 over 6. So we are going to give you an example of another things you should know about GCF and LCM. You know, when you want to factor, you use GCF, greatest common factor, and when you use you know, adding, subtracting, fraction, all of these, use LCM. The way you use it, you want to find out there are two numbers, 24 and 30. Okay, we want to find GCF. It math and go to num, and then you go down to GC. I'm sorry, I said GC, GCD, GCD. GCD, greatest common divisor. So we find the GCD of the two numbers. Okay, we push enter, and then we write these two numbers there, 24 comma 30. Yeah, 30 is going to be, what's going to be? It's going to be 6. It's going to be 6. Now I will show it to you later that, you know, by later on we talk about GCD and greatest common factor usually, but also some people call greatest common factor GCF too. Okay, we will talk about this when talk about factoring, and then let's talk about an example that there are two fractions we were going to add together. Okay, let me talk also about least common multiply, LCM. The same way you push math and then you go to num. Highlight, push this one, go to num, and then you go down here by this, moving this cursor, LCM. LCM, push this one and you put the two numbers that you want to find the LCM of those. Like the same examples, 24, you find the LCM of 24 and 30. It's going to be 120. See, in all exam in college, they let you use calculator. You don't have to go to basic math to learn about those. But we'll talk about it later. You know how to get GCD and LCM of the some numbers. Okay, now let's talk about the addition of fractions. So what you do, alpha, and then first one n over d, enter. We write these two. Let's say numerator is going to be 5 and denominator is going to be 24, and then plus we are going to add. Use another fraction here. The numerator is 7, the denominator is 30. I choose the same numbers. See, here we have to find LCM. You know, the LCM of 24 and 30 is it going to be, see, we get 120, and then so what it does is say the LCM of these two numbers is 120, but we could do some other way. If you multiply 24 by 30, it's going to be 72. Okay, and then 72 divided by 24 is going to be 30. 30 times 5. Okay, we can write it in this way, that we get, I will show you later on that, or we talked about it, I think we can multiply 30. It's all rule, you know, it's just the rules of addition and subtraction of fraction. The rules say that see, you find GCF of that, LCM of this, and then, you know, it's good. But you could do some other way, you know. Let me show you here that I think I can write it in here. You can see it. 5 over 24 plus 30 over 7. The general rule. Any fraction they give you, you just do this. 30 times 24 is going to be 720. Okay, what you do then, 720 divided by 24 is going to be 30. 30 times 5 is going to be 150 plus 720 divided by 30 is going to be 24, and 24 divided by 7 is going to be 165, 168. Let's see what's going to be 150 plus 168, 318. Okay. Or maybe I should write it this way. There is not enough space. I'm sorry. I think you can see this one, 524 plus 37. If you multiply these together, see if you multiply 30 by 24, 30 times 24, we call it 720. And then what you do is divide 720 by 24, it's going to be 30. 30 times 5 is going to be 150 plus 720 divided by 30 is going to be 24 times 7 is going to be 168. So the answer is going to be 318. Yeah, 318 divided 7. So 318 divided by 720. You can simplify. This one, say this one we can divide it by this one by 2. Is going to be 150, 159, 360. Because these are divisible by 2, right? And now we can simplify because the even number at the end. Now we're going to simplify this. So we are going to simplify that. See, we cannot divide both by 2 because this one is not even number. So we can divide by 3, I think, because if we add these two together, 151 plus 5 plus 9, this one is going to be 3 plus 6, you say 15 is going to be 15 over 9. So what I was trying to say, this 15, add this together is going to be 15. We can divide 15 by 3. That we can divide this one, 3 by 6 is 9. So 9 is divisible by 3. 15 is divisible by 3. So we can divide both by 3. See, make sure that you, if you multiply an integer, you have to multiply both of them by a number, that number by numerator and then by denominator. If you multiply this one by 2, you have to multiply this one by 2 too. So now with the division is the same. 159 divided by 3 is going to be divided by 3. And this one divided by 3. Is going to be 53 over 120. That's, see, we got the answer here, 53 over 120. So the calculator, it simplified itself And so we talk about some other things. Let's if you want to ask a square root of see a square root, this one, if you push second, this one is going to be the radical sign. It's radical 5. Okay, and then you see the answer is 2.23. Or a square root of a square root of 2. A square root of 2. It's going to be 1 4. These are irrational number. I mean, you cannot find the same decimal number, not repeated the same decimal number every time. It's different decimal number. You know, like it's different from point. Oh, let me clear. Like 0.33, you know, is repeated. You can change it. You can change it to fraction. You know, math fraction, and then this is the. We can change it to fraction, so it is rational number. Now, let's talk about like multiplication of this a square root. So let's see, in math you can find even to the power of 3 or cubic root. See, if you want to find the cubic root of this, 8 is going to be 2. See, now a square root of see, actually 8 is going to be 2 over 2 to the power of 3. 3 to the with the index 3 is going to cancel out, and it's going to be 2. The 3 to the power of 3, you know, is the same as like 27. You know, 3 times 3 times 3, 27. So actually is 3 to the power of 3. What's going to happen? The 3 cancels out. 3 with power of integer inside the radical. With that, if there are 4 here and it's going to be 4 here, it's going to cancel out and we are just right. So it's going to be 3. 3, the exponent with the index of that radical is going to cancel out, and you're going to have 3. So let's talk about pi. See, the second, this one is going to be pi. This is also a number that we call it irrational number. Like if you want to raise it to the power of 3, 3 times 3 times 3, you know, it's going to be, you write pi to the power of 3. Means 3.14 times 3.14 times 3.14. See, so it's going to be 31.06.